Okay guys, we ran short on that other one. The clock goes so fast when you're having fun, doesn't it? Alright, so let's review the moment here. We're 0 here because there is 0 moment. It is a pin, so we expect that to be 0, which it is, and there's also a roller there, so moment there. So they have to end up there. The first section, this first point here in the moment diagram, will equal the area under the shear curve between that. It's 2 wide by 375 high. Twice that is going to be 7.5. That's where we get 7.5, and we get that. Do the same thing over here from this next section. Since it's a negative area, meaning it's below the shear, it's twice 3.25, so that's minus 6.5. So this is going to drop from 7.5 down that 6.5 area. That makes that into a 1 right there, a plus 1. So that's going to go from 7.5 down to plus 1. And then again, since we have this in a clockwise rotation, it is going to jump up by this amount, the 12. So it goes from a 1 up to a 13. Isn't that cool? Alright, this last part then, how do I get back to 0? Well, this is constant, so I expect this to be linear. But let's just double check. This is going to change by negative the area here, and this is actually 4 across here. Miswrote that. 4 times 325 is going to be negative 12, negative 13. 13 minus 13 takes us back to 0. Boom. Back to 0. There it is. And does that go to 0? Yes, because right here is a roller, which there's 0 moment. So that really quickly just shows us what is happening if we have that. Okay. Now, let me just add to this problem so I don't have to start another video if we had something different. So this is something new here. Okay. What if in this problem we had a moment also over here by some number? Now obviously that's going to change all our initial conditions here with the support reactions. It's going to affect some of this other things here. But if we just look at this last section here, what would happen is, since that is still clockwise, it would right here cause this, whatever this came up to be, to jump up by that number. Okay? It would go up by that number if we had a moment there. Okay? So if it's there or if it was coming this way, whichever direction, it would jump up. So it's there, it's clockwise, it jumps up. Obviously if it's counterclockwise, it'll jump downward, but that still brings us back to 0 if that was a separate problem. Okay? So just a quick review here of what we've gone through. Concentrated forces, number 1 here, concentrated forces. If it's down by a certain amount, the shear diagram will jump downward by that same amount of the force. Okay? The change in shear between 2 points. Okay? Right here we find the area under, that's going to equal the moment. And then if we have a clockwise moment like we do there, the moment will jump up. That's what we had here by going up by 12. Now the one I didn't put in here but we should add, and this is an important one, when the shear diagram equals 0 or when it crosses 0, like right there, okay, when it crosses 0, what we're going to have is a minimum or max in the moment diagram. So when I reach that point right here at 2 meters, I should have a minimum or maximum. This turns out to be a maximum, but we should be looking that things are going to start changing there, okay, when it crosses 0. So now there are others that are listed in my notes. These are probably the 4 most common that you most likely could use. Again, unless you get something really complicated, I usually use these as a confirmation of what my calculations are. Because it's real easy, not real easy, but if you make a mistake in these, there's no real work to back it up. So I would continue to use the old method and use these where you can just to confirm your solutions. Okay? I think we have one more video just to talk about cables, which finishes up chapter 7 for us. I hope this is working for you, and we'll see you in that one too.